So we've talked a lot about evolution and then how Earth has changed throughout the years, and so how those things can kind of tie together. We're almost wrapped up with this chapter, so today we're going to talk about some different patterns and how evolution actually occurs. So we're going to start with some different rates of evolution. Okay, so evolution can occur at different rates at different times based on what's happening in the environments, what's changing. It can happen relatively quickly, I should say, or it can happen really, really slowly. And it can happen differently in different clades. And so a clade is a group of organisms that came from a common ancestor. So, for example, we might look at birds now that all have a common ancestor, or mammals that all have a common ancestor. That would be considered a clade. And those can be really wide and broad, or a little bit more specific, depending on what common ancestor you're talking about. So our two rates that evolution can occur at, we have gradualism. And so gradualism is going to be when you don't have a lot of change. It happens very gradually, okay? And so in this, we can see the fossil records that physical structures only changed a little bit over long periods of time. So over a long period of time, you have a little change, another little change. So over that whole time span, you're going to have evolution happening, but it's not going to be super noticeable between one fossil organism and the next. And so that's gradualism. The opposite is punctuated equilibrium. And so punctuated equilibrium, you have a period of equilibrium where things are relatively unchanging, okay? Not a lot's happening. And then that's broken up by a time where there's a lot of new species appearing. The existing species change a lot, okay? And so that's punctuated equilibrium. And again, we say rapidly. This is rapidly in geologic terms, so it's not like in 2 days all of a sudden we have a bunch of new species. Okay, it's still going to be generations, but in the 4.6 billion years that Earth has formed, rapidly, and since Earth has formed, it's rapidly in those sense. This is going to be, for example, a time of this would be like after the dinosaurs went extinct. That obviously changed the environment, that obviously changed a lot of ecosystems, and so then that kind of opened up a path for a lot of mammals and smaller organisms to evolve and change into the species that we know today. Okay, so it was relatively unchanging for a long time, something big happens, and then we have a lot of change in a short amount of time. So that's punctuated equilibrium. Whereas gradualism, it all just kind of happens at the same rate, pretty slowly, and just consistently changes through time. Then we're going to talk about some different patterns. And these are going to be patterns that are going to tie right into things that we've already talked about this chapter, which should help. So macroevolution, we're going to talk about microevolution next chapter, but macroevolution is looking at changes in those larger clades. Macro means large or bigger, okay? So larger clades, like again, if we're looking at birds with common ancestor, and it's looking at big changes in their anatomy, in their ecology, or in their behavior. Okay, so just changes in those larger clades, not in one individual species, things like that. So we have two of these patterns. The first one is going to be adaptive radiation. And this is going to be when one species is going to evolve into several new species. And usually this is going to be when the species migrates to new environments. Okay, so this we've already talked about. We just didn't give it the term when we talked about the Galapagos Islands with those tortoises and the finches. Okay, so we had one species of finch. It went out to all those different islands, and then they had different food availability, they had different ecosystems to live in, and they adapted, right? Natural selection helped them adapt to those ecosystems, and now we have all those different species of finches, and you can see that in that picture up in the top right corner. Okay, so that's adaptive irradiation. So they spread out, right? They radiated, and then they all adapted to those environments, and so now we have a bunch of different species. The other pattern is convergent evolution. So if you think convergent, if you converge on something, you're all coming to the same place. So convergent evolution is when you're going to get a lot of similar characteristics, again, in organisms that aren't related. So this we've talked about a few times, looking at the emus and ostriches and rheas and kiwis and all those big flightless birds. So they aren't super closely related, but because they live in similar environments, all of their, or a lot of their traits or characteristics are similar, right? They converge on similar traits or characteristics because of the environments that they live in that are very similar. Okay, so it's same patterns that we've talked about a few times this year, only now we're, giving them specific names. So those are our macro evolutionary patterns. I've got a couple more for you, or one more for you, I should say. So we have coevolution. And these are going to be species that are really closely connected. Think about when we talked about symbiotic relationships earlier this year, when they depend really closely on each other. And so when that happens, sometimes they are going to actually undergo evolution together. So coevolution, they're going to evolve when they're connected, okay? And then a lot of times this ends up making each of them so specific that they actually couldn't survive at all without the other. If the other species was wiped out for some reason, the other one would probably go extinct. And it's going to kind of happen gradually. So one's going to change, and then the other one changes to match up with that. And then another one changes, and it changes to match up with that. A really good example is there are species of flowers where their pollen is stored really, really far into the flower. Okay, and then there's hummingbirds that have really long beaks that can get down to the bottom of that flower and get the pollen. So the hummingbird, again, natural selection favored the birds that had the longer beaks. As the flowers were trying to protect their pollen, the hummingbirds have a larger beak, so the hummingbirds need that flower that they can actually get the pollen out of. And without the hummingbirds, okay, those flowers wouldn't be able to reproduce and get pollinated. So they need each other, but it's very specific. Okay, those flowers are very deep, and the hummingbird beak is very long. So again, they fit really closely with each other. So that's our last macroevolutionary pattern. Last thing we're going to talk about are some extinctions. Okay. And obviously extinctions are something you guys have learned about before. This is not completely new information. We talked about how if a species can adapt or can't adapt quickly enough to its environment, you can't survive, you can become extinct. Okay? And we have two types of extinctions we're going to talk about. The first one is a background extinction. So that's going to be a species just fails to adapt to that changing environment or to new competition that comes in. And this is one species that goes extinct. And so when you take them out, the ecosystem that it's left with, that's left, generally is still functioning. It leaves most of your species intact. It's not going to have a huge impact on your environment as a whole. Okay, it's really just one species. Think about, the rhinos nowadays, okay? It's not having a huge impact on ecosystems. On the other hand, we have mass extinctions, which are exactly what they sound like, where you have a large number of species that go extinct over a relatively short time period. And we're talking short as in geologically speaking short. And in this case, entire ecosystems can vanish, food webs can collapse. It's going to throw that ecosystem or that environment into basically chaos because you're taking out a good chunk of that food web. This is things, think like Ice Age coming in, and probably a lot of species go extinct then. Or when the dinosaurs went extinct. Obviously that wasn't just gradually one dinosaur species went extinct, and then another, and then another. Okay, there was a large number of species that within a very short time period went extinct, okay? Mass extinction. And tomorrow we will look a lot more at these. You'll find some examples of both of these. And we're almost done with this chapter.